Hello everyone, my name is Andrei Kvapil. I work as solutions architect at FLANT, and we develop open source software to help other companies to prepare and deploy their cloud native applications. We use Kubernetes a lot. We also have our own Kubernetes platform, which is called DeckHouse. And we also develop wireless tooling to communicate with the Kubernetes and help you to develop, deploy, and monitor your application. But at first, let's figure out what the cloud is and what the difference between the clouds and the traditional virtualization platforms. In fact, they are doing the same thing, providing the feature to run virtual machines on a mount of physical servers. But if we will dig deeper, we'll find out that they are doing this by the different way and they're using their different approaches. And to understand this better, let's back in time when we had no any virtual machines and we had just bare metal servers and we were installing software directly on them. Every time when you need a new rollout, you're actually doing the same things. Buy a physical server with needed system requirements, install operating system on it, configure the networking, install the application, and configure it the proper way. Later, when your server is up and running, you continue taking care of it. For example, you're still managing your software updates and solving other issues. If your server gets broken, you're trying to heal it. So your server and your application is more likely pet, which you've grown and taking care of it. You don't want it to die because you love it. This is okay when you have no much of them, but when you have more pets, it is usually become to be more daily routine. Of course, we don't like routine tasks, and we always do some automation for them. And the virtual machines become to be one of these enhancements because they allows you to take care of your pets the more advanced way. You don't need to buy any specific food for your application. You can just cut some piece from your hypervisor for it. You have fast failover, so it will allow your pet to simply run on another hypervisor in case of hardware problems. You can backup the whole virtual machine instead of making backups using specific application logic. As well, to automate the application deployment process, as many virtual platforms support the automation of the network configuration and the templates in a simple way. But you're still taking care of your application. This means you still have to install and configure it the proper way, even if you are using automation tools. You're managing the lifecycle of every virtual machine because it is crucial for you. If the virtual machine is not working, then your application is dead. That's the main principle. And there are amount of platforms that understand this and deal with it the best possible way for you. Example, the Proxmox and Ovirt have the many features to help you managing your pets and keep them alive in a more smart way. In this way, if your application is like this, it's better to use one of these platforms because they have everything need to you. But nowadays, we have so many applications and we don't want to care about them much. We just have no human power for that. This has given rise to new approaches of the software design and the software deployment. The modern applications can run in multiple instances and consist of many components, which are working independently. Usually they can be scaled horizontally and they are more resistant to the failures. The applications themselves become to be more stupid, but they are more relying on the orchestration platform where they're running on. For example, Docker and Kubernetes. Because the orchestration platforms unify and automate the many things which help you to manage your application. For example, they providing you common logging and metrics interfaces and well-known API for deploying and scaling your application in a cluster. The cloud providers provide you similar API interface so you can interact with this directly. Moreover, they providing you managed services like databases, load balancers, and so on. So you can build your application out of a amount of such building blocks and run them as a single application in a cloud. Your application is not pet anymore, but it is more likely cattle. If one cow dies, you don't care. You just go and buy another cow. But this is not affecting the whole cattle function to give him milk, right? But now we need to know how to manage our cattle because we can't run cattle in a single virtual machine. But we need an infrastructure for that. That's what the cloud platforms were invented for. There are some public clouds, for example, AWS, Azure, Google Cloud, and so on. And there are also private cloud platforms such as OpenNebula, OpenStack, and the CloudStack. They allow you to run your own cloud on bare metal servers and interact with it using the same toolset for interacting with the public clouds. Despite the fact that many clouds providing you managed services, they providing a compute power which you can use for run your application. For example, CPU time, RAM, and disk size. The main principle here is that virtual machine is not a thing which is running your application. Instead, the virtual machine is just a necessary entity to utilize these cloud resources. But how to interact with the cloud platforms? Web interface? Of course, it is nice to represent a view of deployed applications, but use it for deploying? This is not our way. All the clouds provide you API to simply interact with them. You can use tools like Terraform to manage your infrastructure as a code. This allows you to determine the needs of your application and spawn multiple environments very quickly. For example, you can easily create and manage few environments for production, staging, and development needs. Or even more, to create and delete environments dynamically, to test some new features before they reach the production. The environments are always the same as the production one, which allows you to avoid the errors while testing your application before the deploying. If you use Kubernetes, it can also handle the communication with the clouds internally. For example, you can use Kubernetes to order new instances, virtual volumes, and load balancers directly from your cloud provider. This makes your application even more independent from the cloud provider, and you can deploy it the same way on any of them. Of course, your application can interact with the clouds directly. You can import cloud-specific library and make your application manage its lifecycle automatically. To create and delete new instances for your application and scaling horizontally in case of your growing. Clouds are usually operate with such concepts as templates, basic images, virtual volumes, and virtual networks. This means that you have to have prepared basic images with the pre-installed operating system and your application ready to start. Templates are used to describe the instance configuration, so you can easily create big amount of virtual machines out of the single template. Interesting fact that storing data on the system disk is a bad pattern for now. You should always keep your data on the special persistent drives to avoid their loss in case of removal of the compute instances. Ideally, you should be able to remove all compute instances from your cluster, then recreate them and be sure that your application didn't lose any state. So this is how cloud-native applications are working. I can see only benefits. It's a full automation of the application deployment and upgrading process. Fast failover in case of one instance dies, the cloud load balancer will just reroute the traffic to another ones. Infrastructure as a code, where everything is described in a code and allows you to spawn multiple environments for the devil purposes. Simplify design of the components for your application so you don't need to handle logs and the metrics. Some Kubernetes can collect and do that automatically for you. And you don't need to configure networking as well. So if you believe your application can be like that, then cloud platforms are definitely a best choice for you. But there is a question, how to develop a good cloud-native application? I can only recommend you reading about the 12-factor app methodology. This would allow you to build the best application design able to run in any cloud. Of course, this is not only use case of the private cloud platforms. For example, if you are a provider, you can consider the cloud platform to build your own VPS hosting because it provides you a good API interface to manage access and span the virtual machines on amount of physical servers. But in this way, you should take care about all those black boxes the users bring to you. Usually the clouds are not giving you any guarantee that your virtual machine will alive and work forever. There always can be some issues. It's better to explain your users the same approach so they will use your cloud the more proper way. Conclusion. If your application is more likely bad, it's better to use traditional infrastructure virtualization platforms, as they provide you all features to keep your application alive and running. If your application is a more like a kettle, the cloud platforms will suit you best, as they have a nice API interface and all features needed to automate your application deployment. Thanks for participating. I hope my presentation will help you to make the right choice. Now I'm ready to answer any of your questions.